Right, we're live soon, almost live. Uh, cool. All right, now we're live. Um, set up a couple of things. All right, I'm about to do the announcement in the Discord channel, and then I'm of course also going to post an invite link to Discord channel in the live chat. Cool. All right, I posted that. Then I need to create the invite. I got the Discord invite link, copy of it. I'm going to post that in the live chat. Right there, posted it. Got the live chat pulled up for YouTube. I need to pull it up for the Zoom meeting. Should be a fun question tonight, by the way. Digital wallet is a Google interview question. Okay, I got the cool. All right, I think I got everything. Yeah, all right. I'm gonna mute myself and then I'll see you guys at 10:45 p.m. Bye, Aaron. Thanks for joining. All right, it is 10:45. I think we are good to get started. We're going to be covering digital wallet. Whoops, why did it deselect? Okay. So in the digital wallet chapter in Alex Shu's coverage for this problem, it had very confusing raft coverage. And I don't think, I think my solutions to this problem are not actually even going to involve raft. It's going to involve more of a sagas approach. And so I'm also going to cover a variation for strong read consistency of Cinder's balance. Yeah, I can achieve that without using raft. And digital Alex Shu's coverage has this very confusing chunk about raft. I'm not a fan of it. I don't like it. The payment service chapter also seems like it has there's some kind of information from that I think you can probably glean off of it. Also, he used scale of 1 million TPS, not 100K. Another resource. So if you're trying to get some inspiration on the auth capture workflow, the payment service chapter helps a bit, but you also might want to look at the Stripe capture flow documentation. It has really solid documentation of the auth capture workflow and how it works. It was pretty solid. I'm pretty sure it was Stripe. It might have been Square. I've referenced this in a bunch of other videos, such as my own payment gateway video. I'm pretty sure it was Stripe. So we're just going to be doing digital wallet. And so again, this is, I think I already brought this up, but it's a Google interview question, which makes it interesting. Everybody loves the Google interview question. We're going to handle 1 million TPS. It's just sending money across some accounts. You have a balance in one account, you have a balance in another person's account, and you're just handling it within one thing like Venmo. So this is kind of like Venmo. I got my checklist that I neglect all the time. Sorry. Yeah. And then yeah, I don't see any questions yet, but feel free to let me know. Are there any questions about like what I mean by digital wallet, or is everyone clear on that so far? Okay. Oh, I forgot to get rid of this. Sorry. All right. Well, so if you have any questions as we're going, feel free to post them in the chat, and I'll be checking it regularly. Otherwise, I think we're good to go ahead and get started on the diagram itself, which is, of course, the most exciting part that everyone likes to see. So I think most people, so there's already some kind of chat about the design for this ahead of the problem in the Discord channel. And it's like generally there's kind of this consensus that there's like two big pieces to it. It's like this transaction database and then a like wallet database, or like a transaction service and a wallet service. So we're going to start off with so I usually start off with the entry points and exit points, but it's easier to kind of like model the data in this case, which is a little bit more unusual for the problem. But so we're going to have this like transaction DB, have this like accounts DB, or we'll call it the wallet DB, where you have the actual balances of each one. So you like submit a transaction. You're gonna have this transaction come in, and then you're going to go ahead and like do stuff with it. And then oh, I forgot another requirement is that auditing. Yeah, that's kind of important. That's we're going to cover how to do that. It's going to require some special treatment. And I'll show you guys how to do it. It's not too hard. It won't be a big thing to add in this design, but yeah. So like I was saying, you're going to submit a transaction, and then you're going to do the modifications to the sender wallet and the receiver wallet. So let's go ahead and draw out the send. It's got browser, and we're going to have user sending money. And we're going to need a backend, which is the transaction receiving service. So you're going to send money, going to send a request that you want to send some money. It's going to go over to here. And then you're going to do the write to the transaction database. You'll get a response back against the backend. And then you'll be like 200, okay, we've received your transaction request. And this needs to be rounded. Yeah. So you'll have a transaction. You should probably have some kind of idempotency key in case they like double click the button. So you should have some kind of what is it, like deduping key, idempotency key. We'll just say that. And then the from ID, the sender ID. It's user 456. You'll have the receiving ID. And we'll do 678 for that. And you're first also going to want to know how much is the amount being sent. So we'll say we're going to use a string. Money is very interesting and you have to treat it really specially. You can't just store it as like a double or something. You can get all these crazy rounding errors with money. And I think one of the most common ways to store it might actually be a string. Sometimes people just do it as like an int with like cents, like the dollars and cents, or you just I don't know if I've really seen it as a double that much, but usually it's like it's like making sure it's exactly 2 decimal places is rather tricky. Anyways, $50. You could also have the currency in there. I don't really care that much about that kind of detail. It's not really the interesting aspect of the problem. So we got the from account, the to account, we got the amount, we got a key. We're going to send all that, and then it's going to go into the transaction database, and you'll maybe get the transaction ID back or just 200 okay. I don't know if the transaction ID really matters as much in the response because you can always just fetch it on a read. So, I mean, that could be an optional detail though, is the transaction ID. I've seen transaction abbreviated a lot as TXN, so I'm just going to do that for simplicity. And let's do A, B, C, D, E, F, 2, 3, 4, A, B, C, D, E, F, just like that. All right, and we're going to want to store it in the transaction DB, and then we're going to do a bunch of stuff with DB triggers for having it going off to other data sources and changing stuff over there. I see a question in the chat. Okay, yeah, you know, I can cover that right now. So here we should definitely use CDC between transaction DB and wallet DB and have Kafka. Yeah, yep. That's what I'm feeling. Yep. Cool. All right. So the first one is going to be for the wallet DB. These both are going to be horizontally scaled out with sharding over some kind of ID. And then I want this one for the OLAP database for auditing. So for auditing, I think that's going to tend to be some kind of massive key range query. You're probably going to want to have that kicked out to some kind of data warehouse. While over here, this is more of what you would call a OLTP database. And it does not play well with big analytical queries. Neither of these are going to play well with that. Yeah, so you want to kick that out with change data capture. And I guess you can just go ahead and use some like task runners, some kind of like Lambda trigger, or I don't know. It just, yeah, you're going to have some kind of task runners that are going to like pull the, they're going to have the they're going to receive the DB trigger, and then they're going to pass it over to the auditing DB. It's just like OLAP. You could call it a data warehouse kind of thing where you can run your expensive operations. But yeah, you just need to have it sent out somewhere. And so we're going to type Oh, I don't want to have it go over the arrow. That's really obnoxious. So CDC with DB triggers. Yep. Okay, we're going to do the same thing over here, and then over here, I'm thinking we should probably use Kafka. You could even use Kafka over here as another option for decoupling them. In fact, you know what? I can go ahead and just do that. That would have maybe made more sense. Send it to the front. Let's stick it right there, and yeah. Yeah, it's probably going to be on like a different team. Like it's like the people that do stuff in the data warehouse are probably not going to really interact with people that are handling the transaction service over here. So it'd be good to decouple them with something like a stream or something. And so this guy is going to pull messages off Kafka and copy that data over to the OLAP table. Cool. I am going to need to talk about the schema over here at some point. We, of course, will also have a stream over here. I'm going to maybe flesh this out a little bit more first. So we got our stream over here. And then we're going to have this guy that is horizontally scaled out as well. And yeah, maybe I can go ahead and talk about the schema over here a little bit more before I come back over to this. There's going to be a couple of options for how we handle the saga over here. Yeah, but you're going to need something over here. It could be AWS Lambda triggers or just Lambda functions, or I'm thinking maybe orchestration might even be a good idea over here. Yeah, I'm kind of leaning on the side of orchestration over here. But yeah, let's maybe dive into the schema over here next. I'm going to check the chat first, though. Okay, so is DB trigger same as transaction plus outbox pattern? I don't know what the outbox pattern is. Let me look that up really quick. Yeah, I'm just not really familiar with what the outbox pattern is. I see two-phase commit mentioned in here. It's giving me, it reminds me a little bit of what Alex Shu had in his chapter where he used the term command. Yeah, so 2PC does have. Yeah, 2PC is not really an option. It is rather unreliable. I imagine this is like a write-ahead log and DB trigger. Okay, somebody has some stuff that they've written. DB trigger is just one implementation of CDC. The transaction set outbox pattern is used to ensure exactly once message publication. So delivery of messages exactly once is really tricky. And yeah, that's one of the challenges of this problem is item potency. I think I can go ahead and move on from this a little bit. I'm just not familiar with the outbox pattern. That might be one of those things like Patterns of Enterprise Architecture by Martin Fowler. So yeah, I'm not really familiar with that. I'm just doing DB triggers. And CDC does stand for change data capture. There's probably a couple ways to go about it. I know that DBzium with PostgreSQL is a popular solution for DB triggers on Postgres. And then with DynamoDB, it does just have straight DB triggers. And apparently they work really well. Anyways, I was going to cover this schema. So we got the transaction database. We're going to have again the amount, the to account, from account. So we're going to have this stuff again. And I think we should have a transaction ID. And that's going to look something like this. I don't really know how that'll be generated. I was thinking something kind of like Snowflake, Twitter's Snowflake thing. But I think anything really works. You're really just kind of using it as a source of truth. So you could shard over this, you could shard over, you could use one of these as the partitioning key, but you would of course also need the sort key and maybe like the timestamp or something. You need some kind of secondary key. So you need some kind of sort key in order to get a full primary key. But I think either's fine. You could maybe get a hot partition if you do shard over an account ID, which is why the transaction ID might be a little bit better. But otherwise, I don't think you're really going to do key range queries on this thing. You shouldn't really be doing that. That's kind of why it's getting CDC'd out over to the auditing DB is like that's where you would maybe do some key range queries that are a little bit more expensive. Anyways, we got the sender ID, receiving ID, the amount, transaction ID. I think we would probably want a timestamp. Seven zero 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 5 1 2 3. I've just been using that number for everything so far. It's Unix epoch timestamp. And it's just like my favorite one for some reason. And then we're going to have a status. So I think we are going to, I don't think this is going to be, we're not really going to be doing event sourcing over here. We are going to go ahead and update the status. There are things we can do to go ahead and turn it into event sourcing. It would actually be rather trivial to turn it into event sourcing, but it's up to you. Since you're CDCing each of the changes out, I mean, you're going to have each of the statuses also held over here with its own timestamp or something like that. So you can have received. There's like complete status, you can have some other stuff in between. Yeah. Okay. And we would maybe want to tilt this or something to give us a little more space for what I'm going to be doing as it calls back and forth. Yeah, so you can have a message over here. I think you're going to need all 4 of those first items for sure in that message that you're going to send over Kafka. And we've got Kafka, and this is the message schema. Okay. I didn't actually mark any of my partition keys. That was probably kind of dumb. So I mean, this is kind of like a partitioning key. It's if you use that as a partitioning key, that could have that could present an issue with hot partitioning. Or shoot, God, my words are horrible today. It could present an issue with having a hot partition. So it could have like an uneven workload across all the different things. This would make it the most even. This would probably be the best partitioning key. So I like this one the most. I should make text big so you guys can actually read this. Sorry. Yeah, so this one is the partitioning key. And if we use that one, I think that would actually be enough for forming a full primary key with just the transaction ID. And again, I had sender ID as another option, but it could result in hot partitions. Let me move these out since I made the text a lot bigger. Give ourselves more space. Here, I'm going to make this one large too. There we go. All right, you guys should be able to see everything pretty clearly. Okay, so we got that. I'm going to use an I'm going to use AWS steps. I'm going to use some kind of orchestration here. So AWS steps like that. There we go. All right. So you're going to have a message come in, and then you're going to change. You're going to have a message come in. Should maybe just go ahead and go over the steps. And remove the funds from the sender account. You first want to remove it from the sender and make sure they actually have the funds. And then add the funds to the receiver account. And then you can go ahead and update the status on transaction table to complete. I think this is why I didn't want to do event sourcing, is that then you would have multiple transactions on the transaction table. And so then you would do a small key range query. And I think it would just be more ideal to just have one thing. But you can, of course, do event sourcing on the audit table, and that wouldn't really be any kind of harm. But yeah, so that's why I'm not really doing event sourcing on that one. All right, I'm going to go through the questions a little bit. I'm going to cover this one in the Zoom meeting really quick first. So an orchestrator is, it's like a Lambda function. It's similar to a AWS Lambda and AWS Lambda function, but it does several steps and it's really good at retries. It's like really good for retries. It's when you have, it's kind of like a really fancy Jenkins job. It's when you have like several Jenkins job things like in a row, and you have you want to make a series of calls, and depending on how one specific one goes, you might want to do A versus B. It's for handling a directed acyclic graph of API calls really cleanly. So it's like a bunch of Lambda functions that form like a graph. Yeah. Or it's a DAG of API calls and or tasks or something. That's how you think of it. There's a couple of other examples of orchestrators are like Netflix Conductor is an example. It has really nice documentation and it's open source. It's really sweet. Another one is AWS steps functions. And then I think there's like internal to Amazon, there's Herd, which is Amazon proprietary. I'm going to mark that. So you're not able to use it unless you work within Amazon. And then I think there's a bunch of other stuff like Luigi, Airflow, but those are more for like gigantic MapReduce jobs, and they're not really as there's like different types of orchestration too. Oh, there's also Argos workflows. So workflows is another common term that comes up whenever you talk about orchestration, is that you have this like workflow, this like series of steps. Yeah. Is it just a bunch? Is it just a coordinates a bunch of different services? So coordination is a really special term that's usually used for distributed transactions like Raft or something. And so I don't want to use the term coordination specifically, but like you are kind of on the right track there, is that it's good for making a series of calls to a bunch of different services. The specific term coordination, though, is special. That's a special term that is usually associated with, like, if you're going to use yeah, like zookeeper or like Spanner has a thing that, or Raft or Paxos coordination. It's like a strong consistency thing. We don't want to actually do that. So I wouldn't use the specific word coordination, but you're on the right track there. Yeah. You look at the other questions in the chat. It's not one or the other, rather they are just different things. Oh, the outbox pattern versus DB trigger. I'm just looking through the YouTube comments right now. Yeah, I honestly don't know what the outbox pattern is. That might be in the patterns of enterprise architecture, and it's cool. But I'm just not familiar with it. Thanks a ton for covering that. What DB are you thinking for both services? Good question. Good question. So we don't want to use Cassandra. We explicitly do not want to use Cassandra here because it's leaderless. You need a single leader database. So we're going to need something single leader, because then you can actually get proper consistency. So DynamoDB might be an option. It is actually single leader. Spanner would work, but I mean, you don't need that level of consistency. You could even do like manually sharded PostgreSQL, could even work, but I think that's overkill. I just need something single leader, and DynamoDB covers that. I used to use that everywhere in my older videos. It also provides strong read consistency. You can get strong read consistency, as in read your own writes. And so that would be ideal for being able to pivot over to the variation that requires that for the sender's balance. And I'll show you what we can do for that later in the video. But DynamoDB, I think, actually works fine here. It is a B tree based one instead of LSM tree based, but I don't think I think Spanner's the only LSM tree one that's also single leader, and it's overkill because it has that whole true time API and the atomic clocks, which are crazy. So this one is the transaction DB schema, and I'm feeling DynamoDB. And then I want to like fit this below that, but like it's like, oh, I know what I can do. I know what I can do. We're going to stretch these out over there. And then I'm going to move this over to here, give ourselves more space. And then I'm going to make this one large so you guys can actually see it. I'm going to make this one large so you can see it. And then I can drag this a little bit closer. Yeah, so I'm feeling DynamoDB over there. And then over here, I'm also feeling DynamoDB for strong read consistency. And then it also has DB trigger support. That is actually a thing that's not in everything, is that Elasticsearch at least did not have DB triggers for the longest time. And you also definitely did not want to use it as a primary store for the longest time. Somebody posted that it's gotten a lot better. I think Jepsen.io, their analysis on, I think they just totally roasted Elasticsearch in there or something. But yeah, Elasticsearch does not have a good reputation. I would not recommend it on this problem. Okay. So the wallet DB, like I said, I'm also feeling DynamoDB here. I don't know what else is single leader and isn't overkill. So I just want something that is between Spanner and like I don't need Spanner, but I can't use Cassandra. And so like I just don't know what other options there are than DynamoDB. And so yeah, that's what I'm using. And then I mean PostgreSQL of course also works. We might actually switch over to PostgreSQL for my later designs on this. We might actually be using manually sharded PostgreSQL on some of my later options. So I'm actually gonna write that on here too. But like for now, we're currently using DynamoDB because I only have one table. I see some solid comments. It seems like the conversation about the outbox pattern is still going on, which is cool. I love that you guys are able to share so much information in our live sessions. It's really what I think the advantage is of what I'm doing over other groups. There's a massive comment about that. Thank you for typing all that out. We obviously have to share that. And oh yeah, thank you for bringing up CockroachDB too. Yeah, that is an option, and it doesn't require the custom. You don't have to do their custom hardware when you're doing CockroachDB, and you can literally run it anywhere. It's not restricted to Google Cloud. So CockroachDB, yeah, CockroachDB is has an inbuilt feature for CDC. That's sweet. I didn't know about that. I mean, you just kind of need DB triggers. But if it has something even cooler than that, I was not aware. That's really cool. It could, yeah, it could actually be a good choice. It could be, yeah, it might actually be a little bit less of a hassle than manually sharded Postgres. But manually sharded Postgres would work just fine for what I want to do later. I didn't put the stars around this. Yeah, so we're using DynamoDB for now. And then from the explanation here, Cosmos DB, that's another one. Cosmos DB is sweet. It actually has 5 different levels of consistency. So that would have actually, yeah, I keep forgetting about it. I keep forgetting it's a thing. Cosmos DB is Azure's their own. So every big cloud service has their own like major database that they're like huge on, and they push a lot internally. So for Amazon, it's DynamoDB. For Google, it's Spanner, and then over at Microsoft, it's Cosmos DB. And Cosmos DB is coolest. It's just the coolest thing ever. It was Leslie Lamport works at Microsoft. He's the guy that invented Paxos. He also, I think, like coined the concept of causal consistency and like a bunch of other stuff like in that neighborhood. He's done a ton of cool stuff, and he formally specified 5 different levels of consistency for Cosmos DB. And it's it's cool. It's a cool thing. You should check it out. I don't know if they probably have a white paper on it. It's probably really good. Nobody talks about it. It's really underrated. Right. Okay. Wow. And it also has stuff about the outbox pattern in this. I'm gonna pull that up really quick. There we go. Yeah, I'm not gonna read this whole thing live, but thanks for pulling that up. And I'm just gonna post a couple of these messages over here, just that it's oh, and then CockroachDB uses the outbox pattern. So apparently this is like a major thing that I just don't have any familiarity with. And oh, somebody found the documentation on Cosmos DB's consistency levels. It's, yeah, really cool database there. Okay. I'm looking through the chat again. I don't think I answered all the questions that were in this. I don't think I answered all of that. So I covered the DB. I think I mentioned the partitioning key and clustering key. So NoSQL. Yeah, I'm feeling NoSQL for now, just DynamoDB. And then for one of my later approaches where I can't do that, we'll switch over to manually sharded Postgres probably. And then how would that work for the DB traction? So we're doing eventual consistency with sagas. With this, it's yeah, that's how it's going to work. I think Alex Shu did bring up sagas in that chapter, but then he also brought up raft, which was really weird. Like if you're going to do sagas, you don't need rafts, or it's, yeah, I don't. It was weird. Cool. All right. Yeah, I think I covered all the questions. We can go ahead and move back onto the wallet DB. I'm going to specify the schema for this is, so you're going to have an account ID, of course. So something like, I think one of them was what was it, like 456. Yeah, so we're going to have an account 456 on one partition. And you know, I can even have two of these drawn just to kind of help with clarifying how it's going to look. So we have that, and then we have an account 678 will be on a different partition. So for example, that account lives over here on this one, while this one lives on, let's say, that one. And I'm going to drag these out a little bit like that. First space for us. Those are the steps. Account ID. And then we want the balance, how much funding they have on their account. So we're going to say this guy currently has $523.20 in his account. And then I'm gonna have these individual transactions in order to implement this like item potency thing. So we're gonna have what did I do? Transactions, and then you have like a list of them. So this looks similar to like what I did for the inventory problem. It is a little bit goofy, and so I'm going to have another thing where I have the transactions split out, and so that's what we're going to have for manually sharded Postgres is when I roll the transactions out. But otherwise, you're going to have that, and you're going to have you need the transaction ID, of course, and this is to set up the item potency. It's like otherwise you can't have exactly once delivery, and so if you decrement the account balance, you're not storing the transaction ID directly on the record. Then if you have a dropped ACK, so like you have this come in, you're decrementing the balance on top of writing the transaction ID into your list of transactions. And you're only gonna do this whole transaction if you don't already see it there, because after you do that update of the balance, if you got a dropped ACK like that, if that gets dropped, then the orchestrator is going to think that the transaction never went through. And so then it would like retry the transaction. And so your balance, you'd get double charged. But because that transaction ID there, it would know not to run you need the transaction ID there in order to prevent the double charge from occurring. So that's why we're doing that. And then there's an alternative approach where you split out transactions into a second table, and then you just kind of like have both the tables sharded over the same stuff to, yeah. Okay, so we have the transaction ID, and it's going to be ABCDEF-234, ABCDEF. Yeah, we need the amount. I think it was $50. So this guy is getting charged $50. And then I think we might want a status on it. I did this thing in the inventory problem where it was like flattened versus received. So it's like so you could like come back in and flatten it, but if you just have it in a separate table entirely. So I'm worried about like accruing like hundreds of transactions on this record. And so that's why I have the status, is that you can like receive it, and then you would come back in and you would like delete the transaction or something. Or I think I store the flattened status actually over on this record. And then if I just split this out, I don't even have to do that because I wouldn't have to worry about hundreds of records, hundreds of transactions getting accrued within a single record and possibly maxing it out. There is a max size for a record in DynamoDB, and Postgres even has a limit. It's like 10 megabytes, or it's something rather large. And so, I mean, you're able to put a lot of transactions in there, but there is an upper bound, and so like you can't do it indefinitely. So, anyways, you would pull a message in, go ahead and update the first one, and then when you know that has succeeded, you can go ahead and do the you can increase the amount on the other account. So then this guy is going to receive, so this one's going minus 50. He is the sender. And then you have this guy. And we're going to copy this, and his is going to go plus 50. Now we're going to have plus 50, same transaction ID, and this guy's got $427.70 in his account. Cool. All right. And then once both of those are done, you can go ahead and update the status in the transaction ID table. So that is step number 4. So we have 1, 2, 3, 4. I'll go ahead and add the numbers on there. Got 1, got 2, 3, 4. I'll let it go, whatever. All right, so we got that, and then it goes back over there. I think that covers approach 1. I'm of course going to have a cleaner approach than this for approach 2, where we're going to split out the transactions for manually sharded PostgreSQL. I've got 2 other approaches we're going to try out. I see some messages. You know, I'm going to write down my approaches first, and then I'm going to go through the messages a little bit. So for approach 1, I've got the DynamoDB, and then inlined transactions to wallet records, wallet/account records, and then we're going to do manually sharded PostgreSQL with the transaction table split out. And then like if you have the transactions like that, like it's like you can go ahead and get rid of the transaction table itself, because it's like now we got 2 different two copies of the exact same transaction table. And so then we're gonna that's why in approach 3 it's like remove the redundant transaction table. And I'm going to do a cool thing with a DB trigger off the end of this thing too. And we're also going to have strong read consistency. It's going to be a spicy approach. It's going to be a little creatively simple. It's going to be interesting. I want to, yeah, so we do that. And then, yeah, strong read consistency, DB trigger off the end of the wallet DB. Yeah, it's going to be exciting. Let me go through those questions you guys got. So yeah, somebody had posted the Cosmos DB consistency levels. I do see that. And then we got somebody is got a really long message here. So that obviously really needs to make it into the file here. This is exactly related to the problem you're currently essentially on this flow. It's okay if it goes off by a little bit. I do like to cover stuff a little bit outside the bounds of the traditional problems and cover them more as case studies than just interview questions. Money from wallet, we have, say, for example, order placing service. So there are 2 concurrent transactions taking place here. Okay, this might have to come at the end. Let's say user 1 has 50 in the wallet, transactions 50 to right now. 30. Oh, I don't know if this is actually outside of, I think this is just about concurrent transactions. Yeah, this just seems to be about concurrent transactions. And so if you got a second transaction coming in, this is why you want to remove the funds before you add funds, is that if you remove the funds first and you see that, oh, hey, it's going to overdraw the account. Actually, we can't draw that much funds. We're not going to send the account balance to negative. And so then we're going to say failed. And so the whole time that you send your transaction, and then I didn't draw this in, but you would also have the user watching their transaction. You'd like be polling it, or you could even do a WebSocket. user watching transaction to hit the complete status. So I mean, you can pull up your wallet screen and refresh the page, and then it's just the transaction view screen service. And so you got your transaction DB here, and you're just going to do a read off of it. It's just doing a read. Well, that one is the other one is a write. I'm going to write that really quick. That's a read. And this one is a write. Boom. Just like that. Oh, I flipped them. Jesus Christ. I'm sorry. There we go. So you're going to be like reading that. And so if you fail on step 2, you can go ahead and set the status to failed insufficient funds. And since we're using an orchestrator, it's actually rather trivial to do this because that's just a failure scenario. And you got this like big DAG of calls. And so like 2 fails, skip step 3, go ahead and update it. Like, hey, you didn't have enough funds. And like the other person can even see that because they're the recipient on the transaction. So yeah, it's that's how you would handle. So concurrent transactions, you'd have the other one trying to go through later. Or I mean, you could even have them kind of like racing each other. So if you have 2 submitted and somehow one of them managed to hop the other because it's on a different shard of Kafka. So your transactions are not necessarily totally ordered. You don't have a total ordering for the transactions. I think that's a fair statement to make, is that we don't have to preserve total order of the transactions. If we did, well, we're going to see that in a later approach, is that it'll probably be able to handle that just fine. But yeah, this is just about concurrent transactions, which is totally within the scope of this problem. That's totally within the scope of the problem. I can go ahead and try and read this better at the end, but hopefully that is actually what you were talking about. And then yeah, the Zoom channel, the Zoom chat is just going at it with the information dumps. I appreciate it, guys. I have no idea what all of that. Okay, I think it's just about the Postgres size limits, which is important if you're going to do scaling numbers, which I forget sometimes. All right, I'm looking through the YouTube chat now. Okay. Is step 2 and 3 part of a transaction? So that is a good question. It is we're using sagas. So it is a distributed transaction. It is considered a distributed transaction. But we're using sagas, which is eventual consistency. And so it's not what you would call like a PostgreSQL transaction, which is where it's ACID. So the transactions are not ACID compliant, I think might be a fair thing to say. It's probably fair to say these transactions are not ACID compliant, though. And so like when you're doing transactions though, like with your bank, like you pay for something on your credit card, it'll be like pending for like a whole day or 2 or something. And so you might get strongly consistent reads of your balance, and like your transaction might show up like right after you pay for something. It wouldn't really take like hours to show up on your balance. But for clearing, like to like the receiver account, it like totally takes like a whole day or something, or like to clear out the pending status of a charge. So that's why I think eventual consistency is fair. Although I think we probably want stronger consistency on our reads. It's probably a little bit too lax right now, and we're going to get to that with later approaches. But yeah, I think that's a good answer to your question. And then you said, or are they? That's probably fair. Yeah. So the whole thing is a distributed transaction. The whole thing is considered a distributed transaction, but it consists of independent which consists of individual ACID transactions. Yeah. So there's multiple transactions going on. And when we get to manually sharded PostgreSQL, you will see cross-table transactions. You would see a couple of them actually, but they're of course still like multiple phases, and it still would have eventual consistency overall, even though you are doing independent multi-table transactions. Yeah. And yeah, async is an accurate word. Yeah, async is an accurate word. Yeah. That is an accurate word. And then AWS steps, yes. Yep, they are. Yep. Which is bad, I believe, because what if third step failed? So if the third step fails, it would, so you have retries. So you know, it's good you're thinking of this stuff. That's a sign of seniority. So you got retries. But I mean, if all else ends in your DAG, so like what if the receiver account doesn't exist? What if it's frozen for fraud or something? What if the third step fails just completely? You can roll back step two. You can roll back step two. Yeah, so that's one of the advantages of AWS steps, is that instead of just thinking through the success scenario and the happy path the whole way through, it's very trivial to that's like the whole point of it. That's the point of orchestration, is you have this like DAG of stuff. I've seen some in her that were like 50 steps or something. So yeah, there's options for handling that. And so yeah, I see you asked, do we do a retry? Yes, that is one option. And then how to ensure item potency. Well, so that is why we have the transaction ID in there. That's why we have this, is that you would have this independent transaction in step two, where you would first check whether it's already there. If it is already there, then you don't proceed further. If it's not there, then your transaction would involve decrementing the balance and adding this into the list of transactions, because it's a document database kind of. I've heard DynamoDB described as a document DB. You have attributes that can have JSON blobs inside of them. You can't index within the blobs like you can with Elasticsearch, but you can have blobs and like nested objects in DynamoDB. But yeah, so I have this key. This is for item potency. Yeah, and then when we pull it out into a separate table, you're still able to accomplish the item potency. Yeah. Okay. Yeah, don't worry. I cannot possibly end the session tonight without covering all three of those approaches. I would just not feel, I would not be able to be fulfilled in life. Saga requires compensating transactions. Yes, so that is what else. Yeah, I like the term compensating steps. That's great. Fails will need to manually perform a rollback. Yeah, so it would be, I can even say that is and then to be, there's a failure, you can update the transaction DB status to failed insufficient funds. Yeah, there we go. I'm happy that we actually did detail that out. I like how this like written down on a sheet of paper in front of me, but like I don't actually communicate these things very well. So yeah, thanks. Good questions. And what do we got? Actually, I'm confused at, say there are two concurrent transactions taking place. We deduct money from user one. It failed in user two's. So the user two step is you are adding funds. So you can't go negative in step in step 3, you can't go negative on user 2. So that's why it's ordered this way, is it first tries to remove the funds, and if it fails, then you just say that. And so like maybe you could have maybe the transactions could get reordered in a way where it's concurrent, where you would have you try to do a deduction that would make it run negative prior to a deposit transaction. And so then it could fail while it would otherwise have gone through. And that is, of course, actually a complaint that I've seen with a couple of banks, is that they would actually intentionally reorder the transactions to ding people for overdrawing their accounts. And they might have gotten in trouble for that. Yeah. But I think I've gone over that a little bit. The original idempotency key generated on the client. Yeah, you can do that. Yeah, and then you might even want to you would want to store it. Well, so you would also, so if you also store the, you know what, I did maybe botch this a little bit, is that you would actually do this, and then this would definitely be the partitioning key, because otherwise you would have issues if you don't do that. It's yeah, you need it to partition over that, so that way the record always goes to the same node if you're doing a retry, and then it would see if the key's already there. And yeah, okay, but then you can generate your own transaction IDs. That way, it's like this can be, if this is written by the client, I mean, that sounds dangerous and I don't really like that. But if you generate your own transaction ID, that's better. Yeah. Or I mean, you could send the transaction ID ahead of time onto the client. And so then when they pull up the page, it would already have it there. So I mean, there's a couple of different options there, but you do definitely want to have whatever key it is that you're using for idempotency should be the partitioning key. You need the idempotency key to match. Yeah, thanks for bringing that up. Transaction was deducting money from user 1's wallet, which is user 1. 2, can we discuss more about indexes in WalletDB, as we need to search the transaction ID? Indexes in WalletDB. Right, I didn't, oh, that's right. Yeah, so the partitioning key is definitely the account ID. That is definitely the account, that's definitely the partitioning key here. Thank you. I can't believe I almost forgot that. Yeah. So this is definitely what you're going to use as the partitioning key. And then I don't think you need any sort keys. And then this would be the entire, that is the entire primary key. That covers it right there. Yeah. And since they might be on different partitions, they would be on different partitions. That's why you need the orchestrator and why you need the transaction ID for idempotency. Yeah. I think we're good. I'm going to go on to another approach. Yeah, so we just did approach 1. There, it's extra large text. Cool. All right. Yeah. Now I'm going to stretch all of this out, and we're going to copy, and then we're going to go over here. We're going to paste it, so I'm going to work on approach 2, which is where I'm going to split out this table over here on WalletDB. So we got these transactions here, and it's like, hey, why don't we just roll these out into their own table? So that's what I'm going to do. We are going to delete that. Yeah. And then so this is one of the tables, is the account ID and the balance. And then you have a second table of the transactions. And you know what? I'm going to copy this over here, and then I can do no. Nice. So we got our transactions table. We got so in the WalletDB, we have the accounts table, and then I'm probably going to delete this one. So we have the account table and we have the transaction table, and that does make it a little bit redundant here for a second. And we would of course need the account ID as well over on the transaction ID. And so it would every single transaction over here is going to result in two transactions over in here. One of them is going to be for the sender, and then one of them is going to be for the receiver. You can even have a sender or receiver flag on the transaction itself. Send, receive, flag, and then you can have sender or receiver as that. Although I mean, the sign of the amount would be able to tip you off. If it's negative, that means that you're the sender. But it's like another thing you can do is that sender receiver for figuring that out. And then again, like each transaction is actually going to result in two over here because you need the deposit and also the withdraw, or I don't remember the terms. Okay, so you got these, and they're both going to be partitioned over the account IDs that they end up on the same physical machine. And that would allow you to do the cross-table transactions properly on manually sharded PostgreSQL. And so you don't need, so the transaction ID is still there for idempotency. It still is there for idempotency. You do still need it. But you're going to have your partitioning key, which is, yeah, we're going to do that. And so we got our partitioning key and balance. Do I need anything else? I mean, I guess it would be nice to have the timestamp. It would probably be nice to have the timestamp over there too. You don't need this received flattened thing anymore, though. You don't need that anymore. 167.000.5.123. Yeah, and so this would make it idempotent, and then you don't have to like go back and like delete the records and worry about your account, your account record getting too big. It's split out into a bunch of little records all over the transaction table, but it's sharded, and you don't have to worry about any of that. And of course, we're not going to use DynamoDB because, yeah, we're going to do manually sharded PostgreSQL now. Okay, and so that's approach 2. And of course, now we got our own transaction table over here. And so it's like, do we really need the transaction DB on this side then? Do we need the transaction DB over here? And so that is going to bring us to approach 3. But first, I'm going to check if there's any questions in the comments. Yeah, so yeah, I don't see anything. I think we're good to move on to approach 3. So we got this redundant transaction table. We're going to get rid of that. I forgot to bring up another use case, which is that like what if the user wants to view their balance on their wallet, is that you'd of course also have user viewing account balance, and then it's the account balance read service. And so if the user, you got this user, they have their phone, zoom in a little bit, got this user, they're on their phone, hey, I want to see my balance right now, and then it would look up their balance, and then of course send it back over to the user. It's a little, obvious case, but I wanted to specify it. And now I can go ahead and move over to approach 3. The same thing applies to approach 1. I'm just going to do a quick copy and paste just for clarity. Boom. There we go. And now we can do approach 3. And this one's going to be the weird, mind-bendingly simple approach that kind of surprised me a little. Did I miss anything over on? No, I didn't. Okay. Approach 3. So we got the transaction database. And so what I think we can do is I think we still kind of want to have this OLAP thing here, but this thing itself is a little redundant. We're going to move that up there just to see what I'm missing, but let's give ourselves a little bit more space too. And so I'm going to drag it all over a little bit. Okay, and we're going to have this thing. We want to drag all of this over. So we got this wallet. So you're posting a transaction, and then our transaction, like we already have the account ID of the sender. So you'd write first one, you would first write, maybe I should, yeah, I think it would be, should like update the steps, is that one, write the transaction record for the sender and update their balance. In a single write, it doesn't even go over a broker. You don't even have a broker. You just immediately do the write of whatever we're doing on the first operation. Like everything from this, you're just doing immediately. So you have an immediately strong, consistent read over here. And you even get it for this too. These would both be strongly consistent for the sender. So like if they're reading, if this was going off of this, be strongly consistent for that, the sender. Okay, so we got that. And then so this is moving up over there. This is the old one. We have approach 3. And then I said we still have the CDC with DB triggers. It's just weird because the transaction table is now on the exact same thing. And so you still have this like right there. I want to give it a little more space though. There we go. Okay, so you still have the CDC with DB triggers just off of the transaction table. So you have like both tables there and you're just replicating exclusively the transaction table. I'll note that. Just transaction table. There we go. Yeah. And then so we got that. And then we're still going to have we need the second transaction, right? We need the second one. All we've done is the removal from the original account. What about the receiver's account? So we still need to handle the receiver's account. We have this coming in. And we've already handled the hold on, I want to rotate this a little bit. Sure, that'll do. We've already handled the sender's one. And then we want to handle the receiver's account. We're going to need some task runners again. I don't think we need an entire orchestration thing anymore. I think we can go ahead and we just need one Lambda trigger. So we're going to pull a message off of Kafka, and then it's just going to go ahead and update the other one. I'm going to move this again for more space. Sorry. Got this guy, and he's going to go ahead and do a write over here to the other record. Just like that. Hey, write the recipient's record, update their account over here. Just like that. And again, CDC with a DB trigger. on that one too. And yeah, we just got rid of so much stuff. It's wild. And yeah, we got the same schema. Was there anything that I wanted off of the old one? So I got the account ID, receiving. So transaction table has the account ID. So it's the, oh, and we have the sender receiver flag. So it's like, hey, sender account, here's my ID. And then I mean, you can even just have them both, even though it's gonna, yeah, sender ID is me, that is 456. Receiver ID is, what was it, 678. And then I know there's some way to easier represent that, this and that, but I'm just not really thinking right now. So we've got sender ID, receiver ID, the amount. And then since we have sender / receiver, that would show whether it's positive or negative, and then you can do that. Oh, there's like request versus send on Venmo. So like if you're requesting 50 instead, that would be a thing. I mean, it's pretty trivial to add that. You'd also have like a second flag or something, and then that would be for determining the sign. We got the amount, item potency key. Sure, yeah. Ooh, partitioning key would have to be, you can't partition by the item potency key, but it's the sender. So you do still have the item potency key and you can capture that, but it would still get routed to the same place because you're using the sender ID for making sure that it always hits the same machine. So then the item potency key is, I mean, it's important for deduping still. You'd still want to have the request ID, I believe. You'd still want to have the, yeah, you would still want to have this, but it's not the partitioning key. And transaction ID is not the one for item potency anymore. It would be, well, okay, transaction ID would be for item potency possibly on the recipient's end. And again, though, item potency key is not the partitioning key. You have the account ID for routing it to the right machine. You do need that for item potency. This might be important for item potency. What else? Timestamps on there. Oh, I do like status. Yeah, we do still want the status line. Yeah, I don't think we really need that much else on the account table. I don't think we need anything else. I mean, you could have like, their name and whatnot, but we're good on that. Yeah. There we go. There's our table schema. Cool. That is approach 3. Wild. It's like, so Alex Shu had that big thing with Raft on it. And yeah, I don't see any need for Raft on this. I really don't see any Raft. And we do have we do have strongly consistent reads. We do have strongly consistent reads for the sender. The receivers, of course, still going to require some time for clearing it out. I mean, there's like the rollback scenario here. I still don't know if we need a full orchestrator for handling a rollback. I mean, if it did get complex enough, it's very easy to swap this out with an orchestrator instead, but you can probably get away with just having some Lambda triggers over there. All right, I'm going to look through the chat and see if there's any questions. Hopefully I didn't do anything wild and foolish today, but yeah. Okay, I don't see anything in the Zoom chat. Ooh, hot partition issues. If one count has a lot of transactions, we choose an account ID as the partitioning key. That is a great call out. That is a great call out. Yeah, I did assume that you wouldn't have, I did think through this a little bit, is that you could have, you could do something similar to the flash sale problem, but you'd have the account balance split across several records rather than a sharded counter. So what we can do is that we can treat the account balance similarly to a sharded counter, actually. And then you would want to use the shard ID as part of the partitioning key. I should really note that. And avoiding and making sure it lands on the same machine every time. Yeah, I was thinking about that a little bit and I totally forgot to actually bring it up. See if there's anything else that I forgot. Shard by account. If count is too big, do a sharded counter kind of thing, just like flash sale if there's too many transactions. Yeah. So that would be how you do it, just similarly to flash sale. I guess I could maybe try and draw that a little bit. So we're gonna do let's piece this up towards this thing. There we go. And yeah, I'll come back to that. I'll come back to that. Okay. We combine the transaction table and account table into the same DB, then how do we, it's by account ID. It's by you're partitioning by the account ID over here. Yeah, and then if we partition by transaction ID, then a transaction might land on two different nodes. Yeah, well, you don't want to partition by the transaction ID. That's just something for deduping, is that like, so you landed on the right machine, and then you check if that account ID already has a transaction with that thing. So you can still dedupe it because it's a secondary. Oh, I should specify that it's a secondary index. And the item dependency key would also make for a nice secondary index. There we go. The single transaction might land on two nodes. If we partition by account, then reading transactions becomes a scatter gather. No, it wouldn't, because if you're partitioned by the account ID, you're saying that all the records for a specific account ID land on the same partition. Unless reading transactions becomes a scatter gather. Oh, so if you're trying to find all the records for a specific transaction ID, so if you're trying to find, if you're doing a lookup by transaction ID, then it would be scatter gather. I don't know if we do any queries that require looking up a specific transaction ID though. It would and then we're also we're always storing the sender ID and receiver ID with our transaction ID. And so if you did have transaction ID and you needed to look up the other account involved in it, you would be able to do a query by the ID since you're storing it with the transaction record. Transaction account be yeah, I don't know if we actually do need to do a transaction a lookup by transaction ID. You are right that it would definitely be scatter gather if we we did, but I don't know if we actually need to do any of those operations. That'd be a design killer though if we did. And then we also do CDC with DB triggers over here out to here. And so like I think if you like, so the primary case where I think we might have to do a lookup by transaction ID itself could be if you're doing an audit. And if you're doing an audit though, like that's what you have this table over here for. So yeah, I'm gonna make a note of that. Is I want to acknowledge that for a specific and at high scale and definitely a sign killer where it'd occur outside of the auditing table. And then plus you're able to look up the account ID on the record. Okay, let me look at the other message here, and then I'm going to try out approach 4 after this. If we go with having account balance as a sharded counter, if we get a case where an amount to be debited is greater than sharded, yeah, yup. So when you have when you have a large number of transactions like that, it's likely to be like a merchant or something. It's likely to be somebody that has a really massive account and they're handling lots of small balances. So it might be somebody like Walmart or like Amazon.com, where they've got like $1 million in their account, and then they're handling hundreds of transactions at a time of like $5. And so there should always be enough balance that you would never be overdrawing any single shard. Yeah, you shouldn't be like, if you're handling that high of a volume of transactions, you should never be in a situation where you might be like low on funds. So somebody that has a low amount of funds should not be handling thousands of transactions per second. Yeah, cool. I think we've, oh, right, approach 4, the sharded counter. Right. Yeah, I wanted to handle that. Yeah, the sharded counter on, I mean, you could do this on either design, either the things. You can either do a variation of approach 3 with it, or you could do a variation of approach 2 or 1. So I mean, in all cases though, it's going to be the account that's going to get sharded. It's this record that you're trying to split into multiple things. Which one do I like more? I don't like this one for that, because if it's high volume and you're getting thousands of transactions per second on a single thing, then this is going to fill up really quickly. And so you can't use approach 1 for this. It has to be approach 2 or 3. And yeah, this one, I kind of like this one a little bit more. And you would need to have a shard track somewhere. So we're gonna do yeah, we're gonna copy this one, and then maybe I could even do it on approach 3 too, 3 as well. So you're gonna have this, and then you're gonna have a Add this, and then we're going to have a sharded counter ID is what we're going to call it. We're going to say something like 3. And so it's going to like randomly pick it, I think, with the orchestration layer. The orchestration piece, I think, is going to be the one that like randomly rolls a dice to pick a shard. Or you could even do it over here. But in the end, I think your shard ID is going to need to be stored with your transaction information. And so I think the shard counter is also going to need to be recorded over here. And that would so what if it's two big accounts? Like what if there's something going on between Walmart and a supplier? Say the sender sharded counter ID, and you could say the receiver sharded counter ID in case it's like Walmart and I don't know, cliffbars.com or something. Say maybe it's 7. It's a bigger account. And so we have that, it's 3, and they're more likely to have like $50,000 in that shard or something. That's 52,307. Yeah, there we go. Cool. All right. So we have that, and then on the transaction table, you have transaction ID. You have it over there. And oh, is this where you brought up scatter gather? Because if we're looking up a specific transaction ID off the orchestration thing, that would be an issue if the orchestration component is trying to look it up. And so then you would want to have the transaction ID as the partitioning key. Yeah, you're right. If the orchestration piece is trying to look that up, you would want that to be the partitioning key. And you want these things to basically be the same thing. And you want the transaction ID to be preloaded with the request. So like on pulling up the page, it should already have the transaction ID in it. So you kind of want to combine those two things together. It should actually be merged. Yeah, I see what you're talking about. I'm sorry, I didn't understand that earlier. Say merge these preload. This is totally incomprehensible to read. Sorry. I'm going to preload that onto the page somehow. Okay. And you got your transaction, your shard counter ID for that. That helps you find the proper. So this would also be part of the partitioning key. That would also be part of the partitioning key. You need both. Okay. And yeah, I mean, you also then have it on transaction ID table. It's also sharded over there. Yeah. Cool. Right, I don't see any other comments. I can do another quick variation of approach 3 turned into the sharded counter thing. Shouldn't be too tricky to do that. So we got approach 3. Okay, got the account ID, and we're gonna have sharded counter ID of 3, which is going to be part of the partitioning key. And then on the transaction table, we'll have the sender sharded counter ID 3. And you're gonna have it for the receiver as well. We're gonna say 7. ID is the partition key, and we also need the sharded counter ID as part of that. Yeah. That there's the transaction ID. You need the sharded counter ID coming along as well. Of course. And you need both in case you need to do a rollback. So then that would give you the partitioning key for the rollback transaction. That way it wouldn't be scatter gather. Okay, and then you don't specify partitioning key for Kafka. I think that's everything. Yeah, I think that's everything we need. This was approach for great questions tonight. Great questions tonight. What is the use of sharded counter ID? So it's applying the concept of a sharded counter to the account balance. So you're trying to split it over multiple records. A sharded counter is a little bit obscure of a topic. It's not really something that you're going to find in books really easily. It's the idea that like you have this count of something, and that if the key, you have this hot key that's so hot that you wouldn't actually be able to fit it on. It's being hit so much that it'd be more than one machine can handle. And so that record needs to be handled by multiple machines. You've got this counter or like an inventory count, and you need it to be spread over multiple machines. And so let's say your inventory is 1,000 and you want to spread it over 3 machines. And so then you're going to give one machine 400, you'll give another one 300, another one 300. And so that one's on machine A, machine B, machine C. And that's all it is. That's all there is to it. And you might have heard of CRDTs. You can't actually use that for this purpose because they actually only solve the issue of write conflicts. They can't dedupe. They're not idempotent. Counter CRDTs are typically not idempotent. There's one called a Bloom filter, or it's a forgetful Bloom filter CRDT, and that's close to the concept. I don't recall if it's exact though. And if you're dealing with money and an account balance, I don't think there's anything for account balances in particular that's anything like a forgetful Bloom filter. That's like a nice takeaway for this problem is that there's yeah, I want to like note that somewhere is that I'm fairly certain there's no forgetful Bloom filter thing for an account balance, only for counters. So like it's similar in concept to a counter CRDT, but like it's like money, and so you're not just incrementing by 1 or whatever. Yeah, that's like a really big miss. That's like a really big miss in like what's available out there in terms of tools for handling big databases, is that there's not anything for account balances. That's like standard practice. But I'm just applying the concept of a sharded counter to the account balance, and yeah, it's just for handling a really hot key for a thing. I don't know if I answered your first question. That's all two things here. I'm gonna make sure I answered both of these, and I think we can finally wrap it up. Yes, I did answer that one. We don't need to go over that one again. And then I don't. Oh. Yeah, I did answer both of those. Cool. All right. I think we can wrap it up. I'm going to post these files in the in a pinned comment. Yeah, this was fun. This is a Google interview question. A lot of great questions tonight. A lot of great comments. Thanks a ton for watching. I really appreciate it, guys. Hope you guys learned something and had some fun. I really appreciate you guys watching it. I'll see you guys next week. Thanks a ton. See you guys. If you have any other further questions, feel free to drop them in the Discord channel or in the comments below the YouTube video. I'm a lot more responsive on Discord though. So I'd recommend joining the Discord invite link in the YouTube live chat. So any other questions after the video, I'd recommend the Discord live chat. I'll let you guys go though. Again, thanks for watching. See you guys next time. See ya.